In our previous video, we have discussed about two colligative properties, elevation in boiling point and depression of freezing point. The last one, the fourth colligative property is osmotic pressure. So this osmotic pressure is related to osmosis. So let us see what is osmosis. Okay, you might have studied about osmosis. I'll give you one example. You take a suitable solvent, certain solvent and a beaker. Next, you take a tube which is filled with certain liquid solution, and its mouth is fitted with certain type of membrane which is known as parchment or semi-permeable membrane. Synthetic cellophane membrane is also used. So these membranes are having submicroscopic holes or pores. So now in this type of situation, what happens? During this, some of the solvent molecules which are present in this container enters into the solution through this semi-permeable membrane. Okay, here what we have taken a solvent, let it be water only. Okay, we have taken water in a beaker or in a container. Next, you have taken a certain solution in this type of tube, in this open mouth tube, and now the mouth of that tube is fitted with semi-permeable membrane, a type of membrane. Okay, this type of membrane is known as parchment or cellophane membrane. These type of membranes, they have submicroscopic holes or pores. So there are some naturally available membranes like pig's bladder, animal bladder can be used here. So they allow the passage of only the solvent molecules, but hinders the passage of bigger molecules like solute molecules. Now here there is a concentration difference inside the tube and in this container. Okay, this has only solvent molecules. Inside this we have solvent as well as solute molecules. It is a solution. So this is the concentrated region and this is the dilute region. So this is concentrated region and this is the dilute region. Now what happens? Due to difference in certain pressure, which is known as osmotic pressure, the molecules of solvent enters into the solution through this semi-permeable membrane. The molecules of solvent enters into this tube and level of liquid in the tube increases. Okay, the level of liquid inside the tube increases, and it increases by a height of what? H. It increases by a height of H. Now the osmotic pressure can be calculated by using for the formula pi is equal to H rho G. It's moving against the gravity which is increasing. Okay, it increased by a height of H. So now we are not going to calculate all these things, we are not going to derive these things. So you should know what is osmosis and what is osmotic pressure, that's all. So what is osmosis? Osmosis is nothing but the flow of solvent molecules from pure solvent to the solution. Okay, from pure solvent to solution through semi-permeable membrane. Like so what? Semi-permeable membrane? Membranes which allow the passage of only solvent molecules. Osmosis is nothing but osmosis andre no solvent molecules flow aguvanthadu illinda illige solvent in the solution kadege from a region of lower concentration to a region of higher concentration, or from dilute solution to concentrated solution through semi-permeable membrane. Flow of solvent molecules from pure solvent to the solution through semi-permeable membrane, SPM, semi-permeable membrane. Here I have given the example. See, no need to explain all these things. Here we have separated the solvent and solution through semi-permeable membrane. Now what happens? Solvent molecules move from this side to this side. Movement of solvent molecules from solvent to what? Solution side. Or if you take two solutions separated by semi-permeable membrane. Okay, this is dilute solution. This is concentrated solution. Now what happens? So instead of taking solvent here, okay, solvent na badlige, you take dilute solution. Here you take concentrated solution. They are separated by a semi-permeable membrane. ಈಗ ಏನಾಗುತ್ತೆ? The molecules of solvent from dilute solution move towards the concentrated solution. This is the direction of flow of solvent. So here this process continues till equilibrium is attained. After equilibrium is attained, this osmosis stops. When the pressure becomes equal in both the sides, osmosis also stops. Okay, this is about osmosis. Okay, here definition is important for 1 mark. Osmosis is nothing but flow of solvent molecules from pure solvent to the solution through semi-permeable membrane. Or in other words, it's a movement of solvent molecules from region of dilute solution to the region of concentrated solution. Okay, lower concentration to higher concentration region. Okay, in other words, you can define like this also. Next, I'll give you some examples for osmosis. So, what are the examples? You might have seen. If you put raw mangoes in brine solution or in NaCl solution, what happens? ಏನಾಗ್ತದೆ? ಮಾವಿನಕಾಯಿ ನೀರಲ್ಲಿ ಹಾಕಿದರೆ, ಉಪ್ಪು ನೀರಲ್ಲಿ ಹಾಕಿದರೆ, ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್ಲಿ ಹಾಕಿದರೆ ಅಥವಾ ಬ್ರೈನ್ ಸೊಲ್ಯೂಷನ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿದರೆ, so what happens? These raw mangoes, okay, they shrinks into smaller size. Why do they shrink? They shrink because the movement of water molecule from raw mango to outside takes place. Okay, the molecules of water will come out from the raw mango. Due to that, it shrinks. So this is one example for osmosis. Okay, one more example, the wilted flowers. The flowers ಎಲ್ಲ ಬಾಡಿ ಹೋಗಿರ್ತದೆ, wilted flowers. So it revives when it revives when you sprinkle water. ನೀವು ನೀರು ಸ್ಪ್ರೇ ಮಾಡಿದರೆ ಏನಾದರೂ ಬಾಡಿ ಹೋದ ಅಥವಾ wilted flowers if you spray water, so what happens? It revives because of what? Osmosis. When water enters inside the cell, it revives. So ಬಾಡಿ ಹೋಗಿದ್ದಲ್ಲ ಏನಾಗ್ತದೆ, ಸ್ವಲ್ಪ ರಿವೈವ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. So this is another example for osmosis. Even the movement of water molecules in plants, okay, from root to the other part of the plant also takes place through osmosis. Okay, so these two ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಎಕ್ಸಾಂಪಲ್ಸ್ ನಾನು ಮತ್ತೆ ಹೇಳ್ತೇನೆ. So here the definition of osmosis is important. Okay, don't confuse here. So movement takes place through semi-permeable membrane, through parchment paper, or through synthetic cellophane, or through animal bladder, or from pig's bladder. ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಆಗುವಂಥದ್ದು? From solvent to solution side, or from a region of lower concentration to higher concentration, or from dilute to concentrated solution. ಯಾವುದು ಮೂವ್ ಆಗುವಂಥದ್ದು? Solvent molecules will move from one side to another side through semi-permeable membrane. It is to osmosis ಬಗ್ಗೆ. But it's not colligative property. Osmosis is not a colligative property. Osmotic pressure is colligative property. So what is this osmotic pressure? So osmotic pressure is nothing but pressure that just stops the flow of solvent or osmosis. Okay, the pressure that just stops the flow of solvent or osmosis. So let us explain, okay, or let us know these things. Here I have taken the two solutions. Okay, you can take solvent or solution or anything, so which are separated by semi-permeable membrane, See here I have written P atmosphere plus pi. Here pi is nothing but osmotic pressure. So this is P atmosphere, means atmospheric pressure. So now I'll take this system. Here I have solution, here I have solvent, or here you can take solvent, here you can take solution. Now what's the direction of movement of solvent molecules? Solvent molecules move from solvent to solution side. Is it correct? These molecules move from, the solvent molecules move from this side to this side. This is the direction of movement of solvent molecules through semi-permeable membrane. Now how to stop this osmosis? How do you stop it? So in order to stop the osmosis, we have to apply pressure on which side? to the solution side. Okay, so we have to apply the pressure on solution side. So here we have to apply certain pressure pi. So now it stops the osmosis. Okay, in other words, if I take solution here, solvent here, then what happens? Now osmosis takes place. Solvent molecules move from lower concentration to higher concentration region. Now this is the direction of flow of solvent. Now we have to stop the osmosis. What we have to do? We have to apply certain pressure pi at this site. So now what happens? Movement of solvent molecule does not take place towards this solution. It stops the osmosis. You understood? So osmotic pressure is applied to the solution and not to the solvent end. If you take this as solution, here you have to apply the external pressure. If you take this as the solution, then you have to apply the external pressure to this side using this piston. Okay, understood? The pressure, the external pressure that just stops the flow of solvent or osmosis is known as osmotic pressure. ನೀವು external pressure apply ಮಾಡಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ osmosis continuous ಆಗಿ ಆಗ್ತಾನೆ ಇರ್ತದೆ. ಸೊ ಎಲ್ಲಿವರೆಗೆ ಆಗ್ತದೆ? till the pressure on both side becomes equal. ಎರಡೂ ಕಡೆ pressure equal ಆದರೆ ಯಾವ pressure? when the pressure, osmotic pressure is equal in both the containers. ಇವೆರಡೂ ಕಂಟೈನರ್ಲಿ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಆದರೆ ಅದಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಆಗ್ತದೆ. ಸೊ ಬಟ್ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? ಹಿಯರ್ ದ ಸೊಲ್ಯೂಷನ್ ಹ್ಯಾಸ್ ಲೆಸ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ದ್ಯಾನ್ ಸಾಲ್ವೆಂಟ್. ಸೊ ನಾವು ಇನ್ ಆರ್ಡರ್ ಟು ಸ್ಟಾಪ್ ದಿ ಆಸ್ಮೋಸಿಸ್, ವಾಟ್ ಹ್ಯಾವ್ ಟು ಡೂ? ಯು ಹ್ಯಾವ್ ಟು ಮೇಕ್ ದ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ pressure of the osmotic pressure of solution equal to the osmotic pressure of solvent. So ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಏನು ಮಾಡಬೇಕಾಗ್ತದೆ? we have to apply certain pressure which is known as osmotic pressure. You got it? Yes. Next. So this pi, osmotic pressure, is a colligative property. So that is given as pi is equal to CRT. C is nothing but concentration of solution in mole per liter. Here we are taking concentration in terms of molarity, okay, not in terms of molality. In previous three colligative properties, okay, we took molality as concentration term. Now we are taking molarity as a concentration term because in this experiment we are not going to change the temperature of the solution. This is measured at room temperature only. At given temperature, osmotic pressure is measured. So pi is equal to CRT, or we can write pi is directly proportional to concentration. Okay, or you can write pi is equal to CRT. Okay, C is concentration, R is the gas constant in terms of pressure, T is temperature. Okay, so now I have written this C in terms of number of moles and volume. In terms of molarity I have written N means number of moles, V is the volume of solution in liter. So this is mole per liter, molarity into R into T. So what is W2? Here N2. N2 is nothing but number of moles. Number of moles is nothing but mass divided by molar mass. So here W2 is the mass of solute present in the solution. M2 is the molar mass of that solute you have added. Now N2 can be calculated by using this formula. What is the formula? N2 is equal to W2 divided by M2. Here I have written N2 in terms of W2 and M2. So N2 is equal to W2 by M2. So pi is equal to W2 by M2 by V into RT. Now you rearrange this, you will get this equation. The pi is equal to W2 RT divided by M2 into V. So V is the volume of solution in liter, or M2 is equal to W2 RT divided by pi into V. Here V is always written in terms of liter only, you convert it. Sometime they will give you the volume in terms of milliliter, you convert it into liters. Here R is expressed in terms of atmosphere or bar, okay, not in terms of what Kelvin, joules and all. So temperature is given in terms of Kelvin. So this is about the osmotic pressure. Hope you understood. So osmotic pressure is pressure that just stops the flow of solvent or which stops the osmosis. So it is external pressure applied to the solution side to make the osmotic pressure equal in both the side. Okay, if the osmotic pressure is equal in both the side, then there is no osmosis. Next, we are going to study about the types of solution based on osmotic pressure. So based on osmotic pressure of solutions, two solutions, we classify the solutions into isotonic, hypertonic and hypotonic solutions. So what are isotonic solutions? Iso means same. So in isotonic solutions, osmotic pressure of two given solutions are same. If you have taken two solutions A and B, if the osmotic pressure of both these solutions are same, so then they are known as isotonic solutions. Okay, I will give one practical example. 0.9% NaCl mass by volume, 0.9% NaCl mass by volume, okay, and the fluid, the osmotic pressure of fluid inside the blood cell, they are having same osmotic pressure, so which are known as isotonic solutions. The osmotic pressure of body fluids or fluid inside the blood cell and osmotic pressure of 0.9% NaCl are same. So these are the isotonic solutions. So this 0.9% NaCl mass by volume is known as normal saline solution. Normal saline solution, which is used in injections. Okay, it is safe to inject intravenously. There is no osmosis takes place. You remember this. The second type, hypertonic solution. Hyper means more. Hypertonic solution. Here, solution whose constant osmotic pressure is greater than the other. Again, you take two solutions A and B. If A's osmotic pressure is greater than that of B, then A is hypertonic with respect to B. Okay. Now, I will give one example. If you dip blood cell in a solution whose concentration is greater than 0.9% M by V. Okay, what we have to do? If you dip blood cell in a solution whose concentration is greater than 0.9% mass by volume, what happens? Now the water present inside the blood cell will come out and blood cell will shrink. Okay, this is very important. Okay, blood cell will shrink because of osmosis. Water molecules from blood cell comes out, and because of that it loses water and it shrinks. Hope you understood. What is hypertonic? Hyper andre enu ಜಾಸ್ತಿ. ಯಾವುದು ಯಾವುದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. ನಿಮಗೆ ಕೊಟ್ಟಂತ ಸೊಲ್ಯೂಷನ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಇನ್ನೊಂದು ಸೊಲ್ಯೂಷನ್ಗಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. Here if I take A and B solutions, if A's osmotic pressure is greater than that of B, then it is hypertonic. Example ಕೇಳಿದ್ರೆ ಏನು ಹೇಳ್ತೀರಿ? Solution ಯಾವುದು ಕೊಡ್ತೀರಿ? Fluid inside the blood cell ಮತ್ತೆ NaCl solution whose concentration greater than 0.9%. So you remember this. What happens to the blood cell? When you dip inside a solution whose concentration is greater than 0.9%, blood cell will shrink. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಯಾಕೆಂದ್ರೆ osmosis ಇಂದ. Next, hypotonic solutions. What are hypotonic solution? Solution whose osmotic pressure is less than the other. Again, you take solutions A and B. If osmotic pressure of A is less than that of B, if the osmotic pressure of A is less than that of B, so then it is hypotonic solution. Here now I will give you an example. If you dip blood cell in a solution of NaCl, again you have to dip it in NaCl solution whose concentration is less than 0.9% mass by volume. Now what happens? The concentration of saline solution is less than 0.9% mass by volume. Now the osmotic pressure of body fluid is greater than that of the saline solution. Now what happens? Now water will enter inside the blood cell. So due to that, what happens? Blood cell will swell. Okay, swelling of blood cell takes place. So which is due to osmosis. Understood? Okay, because here blood's inside the blood cell, osmotic pressure is less. So what happens? Solvent molecules from NaCl enter inside the blood cell, through which blood cell will swell. Okay, so this is about the hypotonic solution. Hypo means less, andre kadime irtade. Innondu solution ginta adra osmotic pressure kadime irtade. Okay, now one more important term is about edema. It's a disorder. The people who take or intake excess of salty food or excess salt intake, so there is a water retention in the tissue cells and intercellular spaces takes place due to osmosis. So this is known as edema. Water retention in tissue cells and intercellular spaces due to osmosis is known as edema. The people who take larger salty foods or those who take large intake of salt, okay, so they suffer from this disease or disorder which is known as edema. Okay, but the blood cell will bulge or swell due to osmosis. Next, another very important term in this is reverse osmosis. This will be asked for 2 marks. The definition and its practical utility. What is reverse osmosis? In osmosis, movement of solvent molecules takes place from a region of lower concentration to higher concentration. In reverse osmosis, what happens? Movement of solvent molecule takes place from solution side to solvent side, means from higher concentration region to lower concentration region. When it takes place? When pressure greater than osmotic pressure is applied to the solution side. Now see here, if the pressure greater than osmotic pressure is applied here, what happens? Here solvent molecule starts moving from this side to this side. Okay, to reduce the pressure, solvent molecules move from this side to this side, from solution to the solvent side. This is reverse, exact opposite to that of osmosis. Osmosis is exact opposite idu. So definition is very important. Movement of solvent molecules from solution side to solvent side when pressure greater than osmotic pressure is applied to which side? To the solution side. Okay, see here, at normal pressure, at atmospheric pressure, what happens? Solvent molecule enters into solution. The movement of solvent takes place from solvent side to solution side. You can stop it by applying what? Osmotic pressure. Now pressure on both the sides becomes equal. Osmotic pressure becomes equal, no osmosis. Now if you further increase the pressure at this side, again there is imbalance in the osmotic pressure. Illi ಸ್ವಲ್ಪ osmotic pressure ಜಾಸ್ತಿ ಆಗ್ತದೆ, pressure ಜಾಸ್ತಿ ಆಗ್ತದೆ. So now what happens? In order to maintain the pressure or equilibrium, solvent molecule starts entering into the solution side, solvent side. They will come from this side to this side. Solvent molecules will be squeezed from the solution and it enters into the solvent side. So this is known as reverse osmosis. So what is the practical utility of reverse osmosis? That is used in desalination of seawater. In order to get or extract pure water from sea water, we use this technique, but it takes long time. It's a laborious method, and this desalination takes place through a special type of semi-permeable membrane which is known as cellulose acetate. It's not a most economical method to get pure water from seawater. So this is the diagram. See here, fresh water, salt water is present. Here apply pressure which is greater than osmotic pressure. What happens? Solvent molecule starts entering into the solvent side from the solution side. So here we are squeezing the pure water. So I'll give some examples for osmosis already given. So how we preserve the dry meat? So salted meat can be preserved for a long time. Even candied fruits, the fruits which are preserved by using sugar. So why you can preserve the salted meat and candied fruit, sugar added fruits for a long time? It's because of osmosis. So on this salted meat or candied fruit, slowly bacterium starts growing. But due to what? Due to the presence of sugar or due to the presence of salt, this bacterium loses water. Due to osmosis, they loses water and they sinks and die. Okay, the bacterium cannot grow on the surface of salted meat or candied fruits. It's because of what? Osmosis. Due to osmosis, what happens? Bacterium loses their water and they die. Understood? Yes. So these examples I have already given. Raw mango strings when pickled in brine. Next, the wilted flowers revive when placed in water. So these are the examples for osmosis. Okay, here osmotic pressure definition is very important. Then there's terms for calculations. This formula is very, very important for 3 marks. Next, the definitions of isotonic, hypertonic and hypotonic solutions with example. Reverse osmosis definition and practical utility. Okay.